Hello everyone, welcome to Dakshana e-classroom program. In last lecture, we started discussing about fluid mechanics. We saw what is exactly fluid, definition of fluid, some properties, that is density, variation of density with different parameter, temperature and pressure, and calculating density of mixture. And then we saw a little bit about pressure, the term pressure, what exactly it is meaning, and how a fluid apply pressure, what is the meaning of atmospheric pressure, and like what are the properties, meaning like how exactly a liquid or fluid behave in case of pressure. So that is all we discussed. Next thing is comes is the measurement of pressure. So for that we have broadly we will be mainly we will be talking about two devices, that is called barometer and open tube manometer. Okay, so before starting that, let me just tell you a few two terms that sometime comes, so you should understand their meaning. One is called absolute pressure and another is gauge pressure. What is the meaning of absolute pressure? So it is the pressure, it is the total pressure at any point including atmospheric pressure is called absolute pressure. So absolute pressure means it's basically total pressure that also include the effect of atmosphere pressure. So as I told, if we are having one container, then pressure atmospheric P naught at some depth h. Here pressure we know P, so we know P is equal to what? P naught plus rho g h, if this height is h and this is a liquid of density rho, then I would say P at this point equal to P naught plus rho g h. So this is absolute pressure, right? Similarly, next case come a gauge, G-A-U, gauge pressure. So this is called total or absolute pressure minus the atmospheric pressure. That comes the only effect of this liquid or whatever the system you are talking about. It's primarily it's considered the effect of only that particular amount or that content or that liquid. So pressure due to that we measure that gauge pressure. So mathematically it is the pressure, or you can write absolute pressure minus atmospheric pressure, is it? That is term called gauge pressure. So P gauge will be equal to P absolute minus P atmospheric. That is called your gauge pressure. So like in this case, if I want to calculate its gauge pressure, then P gauge will be equal to P absolute, that is P naught plus rho g h, minus P ATM is P naught, that will come simply rho g h. So this is gauge pressure, right? So that is simply two terms, absolute pressure and gauge pressure. And next is pressure measurement or measurement of pressure, and two devices, that is barometer and manometer. Let me talk about them. Okay, so next is measurement of pressure. So for measuring pressure we have many devices and setups. We will primarily or mainly talk about only these two, that is mercury barometer and open tube manometer. So let me start with mercury barometer. Means what is this device, how it measure the pressure? Mercury barometer. Let me tell you first what is the setup and how exactly it work. So the setup consists of simply a container which is filled with mercury. Let's say it's filled with mercury, and we have one tube, is it? Test this tube something like this. So this is the setup actually. It consisting of simply a container, is it bowl, or like big container, and another a tube. So how exactly it works, what we do actually here. So you must be even knowing that point is that if you are holding, let's say, some empty container, some glass, is it, then let's say nothing is filled in that. If I ask you what is the pressure inside that, the answer should be atmospheric pressure. So anywhere in the atmosphere, in the like on the earth, if that space is open, if particularly especially it is not evacuated, means vacuum is not created intentionally or is it by some machine, then by default everywhere the pressure will be of air will be your atmospheric pressure, right? So that is the thing. So if this is a tube which is not filled, it's like air is there, then also at every point in this tube the pressure of air will be equal to atmospheric pressure. So what we do actually, the mechanism is fill this complete tube with the mercury, fill the tube with mercury, right? Then what mechanism, so it's like now completely filled with mercury. So I'm closing this. I mean, like, you can do it by like hand. It's normally done, not done by hand, by some like apparatus proper. So you can close it, let's say like this, and then inverting it, taking it, and here, is it? So now the tube is actually here, like this, is it? Now what will happen, just imagine, and the length of this tube should be like around 1 meter, like not less than at least like 80 centimeter, is it? You will know the reason why actually, that too. So what happened actually, now let's see. The thing is that if let's suppose this tube is empty, is it, means air is there, and just inverting it and you are pressing it down, in that case there will be like, because inside this air will be there, so if you press it, it will automatically come out. No, like not much mercury will rise into the tube. But here, because we filled it completely with the mercury and then inverted, then what will happen actually here? So in this situation, like here, because it was completely filled with mercury, so if the level is coming down, then some space will be there, so vacuum will be there created, right? So let's say the mercury has come down up to here, this level, then in this space it will be having like vacuum. So in case of vacuum, the pressure of vacuum is taken as 0. Pressure of vacuum is equal to 0 atm or 0 Pascal. This is conventionally, ideally, like perfect vacuum is equivalent to 0 atm or 0 Pascal pressure. So now what will happen actually, because this liquid, this mercury is exposed to atmosphere, so atmosphere is applying some force, means pressure, force per unit area. So this pressure on this liquid is trying to push this, is it, and where it is finding the space, because here it's 0, so it will try to press the liquid and it will rise wherever it is finding space. And here you can see, because there is vacuum, so it will rise in this. If there was no vacuum, definitely no pressure will be rising, because from here pressure is there and inside also there is pressure, so why the liquid will rise in that case? So in this situation, what we do is like we initially filled it and inverted it. So then whatever like, if it was higher earlier here, it will try to slowly come down till the point the pressure at same level, is it, in same liquid must be equal. So pressure we know already at this point is what, P naught, P atmospheric, P naught, and here also the pressure should be equal to P naught. So 1, 2, 3. So the mechanism, I hope like you are clear, you understood what exactly how this barometer is actually working. This is complete mercury. Let me mark it. is it? This is also mercury. So let me again tell you the mechanism. Mechanism is simple. We have one container, big container filled with some mercury. Another we take tube, and tube we are filling the open end, we are filling the tube up to completely, like up to open end, and then let's say closing its end and then inverting it into the mercury container. So then here vacuum will be created if it is coming down, and because this pressure is atmosphere pressure is pressing this liquid because it's open to atmosphere, so because of that this pressure will mercury will rise in this tube, is it, up to some height, till the point is that the pressure at this point is not becoming equal to pressure at this point. So if initially the pressure height level in this tube was higher, then it will come down till the pressure at these 2 points is not becoming equal, is it? So the level of mercury adjust in the tube such that pressure at point 1 becomes equal to pressure at point 2. This is actually the mechanism. So now how, if you are taking it, let's say at another place where the pressure is higher, then what will happen here? More force will be there, more pressure will be there, so the liquid will rise even higher height. So the height of the column in this tube is changing. So if the thing is that if the barometer is taken to a different place, having different pressure, then the height of mercury column in the tube adjust accordingly. Right, this is the mechanism. Now how we understood? So here we know the density of the liquid. So now the concept is at, because it's same pressure, same liquid, so 1 and 2 are say 2 points in the same liquid at same level, so pressure at 1 must be equal to pressure at 2, as 1 and 2 are 2 points in same liquid at same level. This implies P1 must be equal to P2, and we already know P1 is equal to how much? P naught, and P2 can be written as, if this is having let's say some P prime, then I can write pressure P2 is equal to P prime plus rho G into H, but this quantity is equal to how much? 0, because of vacuum. So this I can write P2 is equal to simply rho mercury G into H. And the height is measured experimentally. H is measured experimentally. So we have, and density of mercury we already know. So it was observed, actually normally the standard height H for atmospheric pressure is equal to 76 centimeter or 760 mm. So corresponding to that, your P naught equal to P1 equal to P2 is coming out to be rho Hg into G into H. Substituting the values, rho Hg is 13,600 multiplied by G is 9.8 multiplied by H is 76 centimeter, means 0.76 meter. Multiplying this all complete, we get 1.013 into 10 raised to power 5 Pascal. So that's how we get the value of atmospheric pressure, and I hope you must be clear that what is a mercury barometer, how exactly it works, how we get the value, what is the principle behind it, mechanism, assembling and all that getting. So if you want to measure the pressure of like some different point or pressure at different point by using same setup, what you need to do is you can either carry it to up to that point, automatically the height, this height is it of mercury column in the tube will adjust such that pressure at this point, which will be equal to the atmosphere pressure at that point you want to measure, will become simply equal to pressure at 2, and pressure at 2 will be equal to rho G into H. So this is your called mercury barometer. Here question comes is that why we are using mercury, because it's even like costly, it's not easily available, but still why we are using mercury, why we can't use water, is it? Let me tell you the reason for that too. So let me first explain you what will happen if we are using water, right? Let me first erase it. Okay, so let's suppose we have replaced the mercury with water here also, and then we are trying to get the height. Okay, so let me first tell you calculate that mathematically, because we know the pressure P naught will be, P atmospheric pressure is what? It's equal to 1.013 into 10 raised to power 5 Pascal. Density of water is how much? 1000 kg per meter cube. So now P naught will be equal to what? Rho water into G into height of water column, right? And this should be equal to what? 1.013 into 10 raised to power 5 Pascal. Let me substitute. This is 10 raised to power means 1000. Let me take this okay, G 9.8 into H is the height of water. This is equal to 13 into 10 raised to power 5. So this is simply gone 10 raised to power how much? 2, and then H is equal to 101.3 divided by 9.8, and which comes it's 10.33 meter roughly. What does it mean? That means if you are using a water, is it, instead of mercury, then the height of this column that you will get experimentally will be equal to 10.33 meter. Can you just imagine it practically, feasibility, that you are having one setup and the height of the column is just 2-3 like is it equal to like 10 meter, it's 10 meter. You can just imagine this is around 1 meter, so 10 meter, how big it will be, like very difficult. You need to like have 2-3 peoples or some like is it very heavy setup, so that they are holding this tube so that it's not falling actually. So that doesn't make it like practically feasible, and that's the reason we need to use a liquid which is having very high density, and out of the available liquid, mercury is the heaviest liquid, and that's why we are using mercury, not water, is it? So here you must be, for water, height of liquid column is 10.33 meter, which is very high, and make it practically not feasible. And this is the reason, so we need a liquid of heavy density or high density, because in that case height will be low, and mercury is one of that liquid having highest density or very heavy density. So that's why we use mercury in case of barometer. So this is all about the setup and mercury barometer, how it works, why we cannot use water as liquid in case of barometer. Yes, it will work, but this is the only problem because the height of the tube required will be definitely more than 10 meter, and that will be like very difficult to hold, make it almost practically not feasible, right? So let's see, next setup is open tube manometer. Okay, so next is open tube manometer. Here the setup looks like this. We have one tube like this. Normally one arm is taken as like longer, or you can have like both also. That's also no problem. Another container. This is the container. Some gas is filled in this, and we want to measure its pressure. So let's say initially it is closed. So pressure of this container is P, and we want to measure it this. This container is connected to one of the open end of this tube, and then what happened actually? So normally, like when this tube, like it's filled with some liquid, of density rho. Here also, like mostly we use mercury, but it's not like a problem. Depending on what is the pressure here exactly, you can use different liquid also. It's not like compulsory, but normally we use mercury here also. So this is one tube. So when it is like both ends are open, pressure here P atm, P atmospheric, so level of liquid in both the arms will be exactly equal. So what happened actually when this is connected here? So let's say this arm, is it, this container is connected to this arm, then what will happen? If pressure inside, and let's say this is allowed, what will happen? If pressure inside is very high, let's say, what will happen? It will press it more. So, is it, so force will be, so what will happen? The liquid will start rising in this arm and it will come down in one arm. So because of that, this situation will arise. Let's say liquid in this is up to here, and this arm liquid rises up to there. I hope you are understanding. Similarly, if the pressure inside this is, let's say, low, what will happen? It will compress it further, atmosphere pressure. So maybe there is possibility that here it's rising, here it's falling. What will happen? In that case, the pressure inside this container is low. So one more thing here is that open tube manometer, it measure the gauge pressure, not absolute pressure, right? And now how exactly it measures, let me tell you. So pressure, let's say inside this container is P, this open to atmosphere, so pressure will be P naught, and now you can see this height, like this is the bottom. So from here, this height, let's say it's y1, height of liquid column in this tube 1 or arm 1, and this is y2. Now pressure at this point, let's say 1 and 2, is it? So pressure at point 1 and 2 must be equal, because it's in same liquid at same level, as both points are in same liquid at same level, right? That's why. So pressure at, then now what I can, like, so pressure here P, then this is also here, also it will be P. So what is the pressure at 1? So what I can write, P1 is equal to what? P plus rho is the density of this liquid, rho G into y1. Exactly in same manner, pressure of point 2 can be expressed, pressure here, that is P naught plus rho G into y2. Is it? y1, y2 easily we can measure. Density of the liquid we already know. So now just equating these two, and pressure we need P, is it? So as P1 equal to P2, this implies P plus rho G y1 should be equal to P naught plus rho G y2. Is it clear? So from here All right, we can get this is all okay. So this implies we can get P is equal to P naught plus rho G y2 minus rho G y1. Is it understanding? So in this manner we are getting actually the total pressure or absolute pressure of this container, and gauge pressure will be simply equal to the difference in height. Is it? So just 1 second. All right, so up to here, and this can be further rearranged. Just 1 second. Okay, so we got it up to here. So this implies this can be, so pressure, this is the absolute pressure is equal to P naught plus rho G, this y2 minus y1. Is it? So if we want absolute pressure, actually absolute pressure can be also measured from here, because rho and difference in height can be measured easily. P naught we already know. So this is actually absolute pressure of container, and gauge pressure, that will be like P minus P naught will be equal to rho G y2 minus y1. So this is gauge pressure that can be also measured very easily. So normally, like, because we know the density of the liquid, we simply measure the difference in height, then directly we get the gauge pressure, and the absolute pressure can be calculated by just simply adding this PATM. So this setup is your open tube manometer, because one of the ends of the tube is open to atmosphere, one tube, and this pressure measuring, like in which we want to measure the pressure, this setup connected in this manner, the liquid will change. So if your, let's say, pressure is higher, what will happen? It will further go down, the difference y2 minus y1 will increase further. If the pressure different, like in this container, is low, then automatically this difference will come down. So based on that, this gauge pressure can be measured easily, and this setup is termed as a open tube manometer. So the point here are regarding like solving this type of problem, and the concept that you need to remember is that in same liquid at same horizontal level, the pressure at both the points must be equal. So I hope you understood. These are two pressure measuring devices. Let's see some applications, some problem based on it, because some good questions are formed on it, and that is normally asked in the exam. So let me explain you those. Okay, let's see some problem, some application of the concept we have seen. So first one, if pressure at half depth of lake is equal to 2/3 of the pressure at bottom of the lake, then depth of lake is equal to. So let's consider this is a lake, and here pressure is PATM, and this is the bottom. Okay, then what I will write, and its depth, let me take it h, then pressure here will be equal to what? P naught plus rho G h, and half of the depth means here this is h by 2, so pressure will be equal to what? P naught plus, this is P1 P2, P naught plus rho G h by 2, right? This is the pressure at bottom, pressure at half of the depth, half of the, so pressure at half depth of lake is equal to, so it's given, I can write P2 is equal to P naught plus rho G h by 2 is equal to 2/3 of pressure at bottom. So this is equal to 2/3 of pressure at bottom, that is P1. So this implies P naught plus rho G h by 2 equal to 2/3 of P naught plus rho G h, is it, of the okay, pressure at bottom of the lake, then depth of the lake is, so we need to find here h. So just simplifying it, we can, this is a space, I think, like it's P naught, just taking it this side, then it will be like this term this side, this term here, so it will be like P naught by 3, and it will be like rho G h, this is what, 2/3 plus taking it this, it will be minus 1/2, so taking it's 2/3 minus 1/2, it's 4 minus 3, it's 1/6 basically, so it's into by 6, right? And then this implies h is equal to P naught, P naught is given as P naught into this is also 2, so this is 2 p naught divided by rho into g. Substituting the values, 2 p naught is equal to how much? 10 is to the power 5, rho 10 is to the power 3 into g 10 is to the power 4, so 5 means it's coming out with 20 meter. Here space is a little bit congested, but I hope you should be getting it. Concept, so this is a lake, atmospheric pressure P naught, that too it's given, you need to take it 10 to the power 5 Pascal. Then pressure at half of the depth is equal to P2, let's say P naught plus rho g h by 2. At bottom I can write P1 is equal to P naught plus rho g h, if h is the total height of the total depth of the lake. Then by using this relation, that at this point is equal to 2/3 of pressure at bottom. So we got this, and just rearranging it, simplifying it, we are getting the value of h, that is coming out to be 20 meters. So this is the answer. Question number 2, a barometer tube reads 76 meter of height. So means this height of the mercury column in the barometer tube is 76 centimeter Hg. If the tube is gradually, so this is the original orientation of the tube, now it's tilted. It is gradually inclined at 60 degree with the vertical. So this angle is now made 60 degree with the vertical, keeping the open end immersed. So this open end is still immersed in the mercury reservoir. The length of mercury column will be, so now the length of the mercury column in the tube will change. I am not saying height will change, I am saying length of the mercury column will change. So this, let's say length become L. Then here important point you need to keep in mind is that, so pressure does not depends on the length of the column, it simply depends on its vertical height. So pressure at this point it's equal to P naught. Now pressure in this situation, so at point 2 and 3 must be equal, is it? So solution, this implies pressure in both cases must be equal. And another point, pressure depends only on height of column, not on length of column. If length become equal to height, then yeah, it will be same, but otherwise not. So now here what I can write in this situation, simplifying it here, further continue. So in this situation I can write pressure is equal to rho Hg into G into H is equal to how much? 76 centimeter. This should be equal to, again in second case density is same, Hg into G into, if length become L, then what will be the vertical height? Vertical height will be L cos 60 degree. So L cos 60 degree. This cancel and L is equal to 76 divided by cos 60 degree, that is equal to 76 divided by 1/2, 76 multiplied by 2, that is 152 centimeter. This is the answer to this problem. So if you are tilting the tube, length of the tube will change to 152 centimeter, but still the height will still remain same. This is problem number 2. Next one, question number 3. So when a large bubble rises from bottom of the lake to the surface, is it? So again here let's consider, so we have, this is a lake and this is the bottom, so large bubble, it rises from here to there, and its radius, if its radius here is let's say r, then here it become 2r, it's mentioned. So its radius double. If atmospheric pressure is equal to that of column of water height capital H, then depth of the lake. So here what happened actually, let's say here the pressure, I would say the height of this lake is H. Then I can write pressure here will be equal to what? P equal to P naught plus rho g H. And here pressure, because it's almost in this contact of surface, will be equal to P naught, right? And this is also mentioned, atmospheric pressure is equal to that of column of water height H, means P naught is equal to rho water G into capital height H, right? Now the drop as it's going upward, because pressure is decreasing, so it will expand. So here we can almost assume the temperature of air inside bubble, temperature of air inside bubble remain constant. Normally it happen, and I'm assuming it in this situation. Okay, so now what we can do, then here we need to apply some relation from thermodynamics, that P1 V1 is equal to P2 V2. So this implies P1 V1 is equal to P2 V2. This is P1, this is P2, and volume here, let's say V1, here volume V2. So P1, just substitute, P1 is equal to how much? P0 plus rho g h. V1 4 by 3 pi r cube. P2 is P0 into V2 is 4 by 3 pi, and r become 2r cube. Clear? Let's simplify it now. So it's P0, and I can substitute this value also. So, and this is also water. So rho g capital H plus rho g small h, 4 by 3 pi, all gets cancelled, this will be like 8. So this is simply P0 into, that can be also rho g into capital H into, this is equal to how much? 8. So now rho g completely gone. So this is we need a small h. So this capital H plus small h is equal to 8 times capital H. This implies small h is equal to 7 times of capital H. This is the answer to problem. So basic concepts are there. I think like here only you was supposed to be familiar with this relation P1 V1 equal to P2 V2, because as bubble rises, pressure is decreasing. So keeping temperature constant, volume will expand. How much volume is expanding, that already provided to you. Pressure in terms of like atmosphere pressure and the height of the lake can be expressed in this manner. Near the surface we can take it almost equal to atmospheric pressure. By writing this equation, substituting the value, simplifying, we are getting straightforward. This is the answer to problem. So I hope you understood all three problems. Okay, so next problem here, you are asked to find the pressure inside the tube. A tube is given like this, and a liquid of density rho is filled in this arm up to 14 centimeter here, and this end is closed. So here it's basically you are asked to find this pressure. Is it the basic idea for calculating or finding like pressure in this situation is we will consider 2 points which are at same level. So let's say this is point A and this is point B. Then we know actually A and B both points are at same level in same liquid, so pressure at point A must be equal to pressure at point B, is it? So then the approach PA must be equal to PB, and PA can be written as what? PA from this arm, it's P0 and plus rho GH, so it's P0 plus rho G, and H is 14 by 100, is it, in SI unit. So this is PA. PB can be written as what? PB can be written as P, here pressure at P, plus rho G H is 6 by 100 centimeter, like this is. So now these two pressures should be equal. This implies PA equal to PB equal to, that implies P0 plus rho G into 14 by 100 equal to P0, this P, plus rho G H is 6 by 100. Just simplifying it, we are getting P equal to P0 plus this, sending it this side, so 8 rho G in by 100, that comes out to be P0 plus 2 rho G by 25. This is the pressure inside tube. So I think like it's a straightforward, simple approach. Logic is consider 2 points in same liquid at same level, calculate the pressure at that like at these 2 points, and just relate it, equate it, simplify it, you will get the answer. Let me solve you one more problem when like different liquids are filled in same tube. Okay, so here consider next problem where like 3 different liquids are immiscible liquids, means they are not mixing, are filled in this tube in this manner, and this is a like vacuum because this end is closed, and so lowest one, because heaviest liquid will be residing, staying at the lowest point. So this is a liquid having density 8 rho, the another liquid 3 rho density, height 2h, and last one is A liquid having density rho and height h is filled. Again, you are asked to find the pressure inside tube. So in this situation also same concept will be applied. Let me tell you how we apply that. Is it? So pressure, I can consider this is point A and this is point B. Then I can write pressure PA must be equal to what? PB. And let me now write PB equal to what? P. Let's say pressure at this point is P plus rho. Density is equal to how much? 8 rho. Rho into G into height is 2h by 3. So this comes out to be PB is equal to P plus 16 rho G h by 3. So we got one expression, right? Next, for calculating pressure at point A. So how we will calculate pressure at point A? This point is pressure is P0 simply because it's open to atmosphere. So now what you will write, pressure at this point will be equal to what? P at this point will be P0 plus rho G h. Clear? Now if pressure at this point is P0, then what I can write? Pressure at this point, let me write this is something P1. Is it? Then pressure at this point is P1, then pressure at this point will be equal to what? P2 equal to P1 plus density 3 rho G into 2h. Is it? It's congested. Let me write. So pressure at point this P2, you can write it's P1, because here just forget about this. I know the pressure at this point is P1, then this is the liquid. Is it? So if I am going at depth 2h, density this, then pressure can be P1 plus density is 3 rho, so rho G into height, that is given as h. Then pressure at point A will be equal to what? PA will be equal to P2 plus rho G into h by 4 height, because here height is h by 4. So in this manner we can actually, doesn't matter whether 2, 3, 4 or any number of liquids are filled in any tube, in any situation we should be able to write the expression for the pressure. And then just equating, because A and B both points are at same level in the same liquid, that's why the pressure at point A and B must be equal. Here you can't equate pressure at this point is equal to pressure, because here the liquid is different. If same liquid will be there, we can equate that too also. It is also not necessary that you will be taking always like both the points A and B at the bottom of the system. No, you can take one point here and another point here, but make sure that both the points are in same liquid, then only you will be able to equate that. Still, if you are taking one point here in this liquid, one point here in this liquid at same level and doing the calculation, we can get still same answer. So now we got the expression for PA, and let me like write. So PA is equal to P2 plus this is multiplying, then it's basically 2 rho G h, and let me substitute P2 is P1 plus this is equal to how much? 6 rho G h plus this is 2 rho G h, and P1 can be substituted as it's P0 plus rho G h plus this 6 rho G h plus 2 rho G h. So simplifying it, we are getting it's P0 plus 6 plus 2 8 plus this is 9 rho G h. This is PA. Now because A and B are at same level in same fluid, then that's why I can equate PA must be equal to PB, and this implies PA is equal to this P0 plus 9 rho G h should be equal to PB, that is P plus 16 rho G h by 3. Simplifying it, P is coming out to be. Okay, so on simplifying this, we got finally this step, and simplifying this, we can get it's P0 plus 9 rho G h minus 16 rho G h by 3, and this is P0 plus, I can take LCM 3 and rho G h out, so this is basically 27 minus 16. Finally we are getting P2 is equal to P0 plus this is 11 rho G h by 3. So this is the answer to the problem. So I hope like even this type, even here 2-3 liquids and any situation like similar to this are given. Now you should be able to answer that. So in this manner we are able to calculate pressure at this point by just using the concept that at same level in same fluid pressure must be equal, and even when more fluids are there you can directly get the pressure at any point when more than more than one fluids are filled. So this is about this problem. Let's see more example. Okay, we have next problem here. The manometer shown above is used to measure the difference in water level between two tanks and calculate this difference in water level of above two tanks. So this is the setup. Sometimes this type of problem appear a little bit confusing. There are two ways you can approach here. Let me tell you how exactly. So first thing is these two tanks is there. Let's say tank 1, tank 2. Both are filled, and the difference in level it's asked to find actually. So let me first consider one reference line. So this is like up to here. Things are almost like this. Then I'm taking from this reference line. This is the height h2. And the height of liquid in this is, let's say, h1. So first thing is this is water up to here, water. So means in this situation like this is also, so I can consider is at this level pressure will be like what? Same? Is it? Okay. Not exactly. I can say this is the, basically these are 2 points. Is it? Because this is open to atmosphere, so P0. This will be also open to atmosphere, so here I can say pressure will be equal to P0. Is it? And these 2 points are in same liquid. Let's say its density is ρ1, and density of water I am taking ρ, density of water I am taking ρ. So then I can write at this point and this point, because these 2 points are in same liquid at same level. So definitely pressure at these 2 points must be equal. Clear? And so let me write first point 1, this is point 2, here 3, this is 4, 5 and 6. Clear? So what we can do is, one way is I can write from this way I can write the expression for pressure at point 3. From this way I can write the pressure at point 4, and then both will be equal. So here you can have P3 will be equal to P4 because these are 2 points in same fluid at same level. So what you can write, how you can reach pressure point of point 3. So first thing is here pressure P0. What will be the pressure at point 1? Pressure at point will be P0 plus P1 will be P0 plus rho G H1. Clear? And this level will be definitely equal to this level because it's connected and at same level. So pressure at point 3 can be written as P2. Now when we are going down, then pressure increases. When we are going up, pressure decreases. So P2 minus rho into G into H is 40 centimeter. Clear? I hope you are understanding. So P1 I got, then P1 will be equal to P2 and P1 is equal to P0 plus rho G H. Is it? Or H1, and P2 equal to P1 and P3 can be written as P2 minus rho G into H is 40 centimeter. So let me take H directly right now in terms of 40 in centimeter. Then this is, I got pressure of P3 can be substituted, so P3 is coming out to be P0 plus rho G H minus rho G into 40. Clear? And from this side, if I move, then what is that? P6 will be equal to what? P0 plus rho G into H2. Clear? And P6 will be equal to what? P5, because this is at same level. Right? So P6 is equal to P5 and P4 can be written as, P4, yes. P4 is equal to what? P5 minus rho 1 G into 40, because this difference in height is also 40. So I got P4 is equal to P5. P5 is equal to P6 means this. So P0 plus rho G H2 minus rho 1 G into 40. Is it? So we got P4 and we got P3. Next thing is, we know because P4 and P3 both are in same level, is it at same level in same liquid. So this implies P equating P3 equal to P4. That means P0 plus rho GH minus rho G into 40 equal to, here it's P4 P0 plus rho GH2 minus, this is rho 1 G into 40. Okay, just equating this, P1 P0 gets cancelled. This is H1. Yes, I need to write it H1, and this is H2. So H1 and H2. Now this implies G can be cancelled. Then I am left with rho H1 minus rho into 40 equal to rho into H2 minus rho 1 into 40. So taking this side, this implies rho H2 minus H1 equal to rho 1 into 40 minus rho into 40. Is it? Right. Let me just check the calculation part. Here we got P3. P3 is equal to P2. P2 is equal to P1 equal to P0 plus rho G H1. Yes. Rho G H1. Yes, that's correct. So we are okay. So that is okay. And here this specific gravity is given as 0.9. Specific gravity is rho 1 divided by rho water. That is equal to 0.9. So rho 1 is equal to 0.9 into rho, because rho water I am taking it rho. Is it? So this is equal to 0.9 rho into 40 minus rho into 40, and here H1 should be even higher, so we are taking it H2 minus H1. So this can be rho into H1 minus H2. Then it will be like minus. So taking again rho common. This is H1 minus H2 is equal to how much? 40 minus and 36. This implies H1 minus H2 is coming out with 4 centimeter. So question is a little bit lengthy, but understanding the question, the logic is more important, is it? Because this is like a little bit important problem. The approach, let me tell you again. Here concept is that at same level, in same liquid, connected liquid, you can say the pressure will be definitely same. Clear? So here what I can say, 3 and 4 are 2 points in connected same liquid at same level. So pressure at these 2 points will be same. Clear? And another is 1 and 6 I cannot say because it's not connected liquid actually. That's why I cannot say. Yes, it's same liquid but not connected actually. So it will be acting like different liquid. So it's open because you can see here it's open to what? Atmosphere. The pressure here will be like, if it is same, then is it? That's not possible. P0 plus rho G H1, then H1 H2 must be equal. So connected liquid is also necessary. Remember that. So we write P0 we know. We got pressure at this point because this is connected at same level. So that's why P2 will be. When I'm going up, then it will be like minus. This is rho G H. So we got P3, then P4, and similarly from this side and just equating it, we are getting the answer, solving. This is the approach, right? Next way is what we can do. So this is the one way. Another way is, we know actually here pressure is how much? P0. Pressure here will be P0, pressure at 6 will be P0 plus rho G H2. Pressure at 6 will be equal to pressure at 5. Then I can write pressure at point 4. So P5 equal to P6 is equal to P0 plus rho G H2. And then I got means P5. So P4 is equal to what? P4 is equal to P5 minus rho 1 G into 40. So finally I got P4. P4 means I can directly move on to P3. Is it? Right. So we are like moving from here to there, and finally we are getting it here. Or you can even come here, and this pressure you can write. So directly you will be easily. And like it's just a similar approach, but just like here, instead of equating exactly here, you can travel up to here also, and then equate this point pressure. So that can be done. So the traveling, how we do actually, how we move from one point to here point, that is the important thing. You need to focus. So what I did is P0 I know, I got P6. P6 is equal to P0 plus rho g H2. P6 I can equate that to P5. P5 if I got, then P4 is equal to what? P5 minus rho 1 g into H. P4 and P3 both are in same level, so I can write this is equal to this. Then I can move on to P2. I got P4, this is also equal to what? P3. Then P2 is equal to what? P3 minus, this is plus rho g H is 40. Is it? So that you can write it's P5 minus rho 1 g into 40 plus rho g into 40. So we got it up to P2, right? And P2 means equal to P1. So this can be equal to P1, and that is equal to P0 plus rho g into H1. Now I can directly write P1. So it's just different like way, but almost like basic concept is exactly same. It's just different way of calculation. So in this situation, P5 you can substitute this. So this implies P5 it's P0 plus rho g H2 minus rho 1 g into 40 plus rho g into 40. This is equal to P1 equal to P0 plus rho g into H1. So this is also exactly like same relation. If you further simplify, P0 gets cancelled, and G you can also cancel from here, G and G. Here you are left with rho H1. Rho 1 you can also substitute. So this is rho. This implies rho into H2 minus this is rho 1 into, so this is 0.9 rho into 40 plus here it's 40 rho, and this is equal to rho H1. Rho can be also cancelled. I am simplifying it now here. So this is how what I have left it. Let me bring that to this side. This is H1 minus H2. What is left here? 40 minus this. 40 into 0.9. So this is left with 40 minus 40 into 0.9. And that's what exactly 40 minus 36. So we are getting H1 minus H2 is equal to, this is 4 centimeter. So we are getting exactly same answer. Simple thing is, one way we got 2 points at same liquid, in same liquid at same level. Moved from here up to here, moved from this side to here, equated those two presses and solving, we are getting answer. Another way is travel from here, I mean like moving from P0 we know, then move to this point, then this point, then this point, then finally this point, and then this point, and then this point. And this pressure can be equated directly, P1 is equal to P0 plus rho g H. Just getting one equation, simplifying it, we are getting answer. So this is the approach. I hope you should be clear with that approach. Okay, so next is Pascal's law. It's sort of like application of behavior of fluid. We harness it. And what is that? So it says, in a confined liquid, externally applied pressure transmit equally in all directions at same level. What it means? So let's consider this is a system where two arms are there. Here this area of cross section is like large, that is, let's say, capital A, and here area of cross section is small a. Okay, that is small. So this is area of cross section of left arm, right? Then what is happening at this point and this point? Pressure will be same. This point, this is 1, 2. So P1 will be equal to P2 because P1, P2 both points are at same level in same liquid, so right now pressure will be equal, right? Now what is happening if and this is confined, means it's like enclosed sort of liquid. If some additional pressure is applied, what I am doing is, let's say small weight is put on it, so force will be equal to what? Force is equal to mg, and pressure developed at point 1, additionally applied pressure will be what? Mg divided by small a area. Now what will happen? The same pressure, because 1 point externally applied pressure is how much? P1. So this P1 pressure will transmit equally in all direction at same level. So means it will also transmit at point 2 also, in this direction also. Is it? So same extra pressure will be passing to point P2 also. Same extra pressure will pass to or transmit to point 2 also. That is because of behavior of liquid. So then additional pressure coming at point 2, I can write, so P1 will be equal to P2, that is also equal to mg divided by 8. This is the additional pressure, right? But at this point I can like balance even heavy weight, capital M. So this is like this principle is used in hydraulic lift. So then P2 can be written as what? Capital M, heavy weight, G divided by capital A, area. So that this pressure is exactly equal. To balance this, so by this principle, small weight can lift a large weight in this manner. This principle is used in hydraulic lift, and this principle is termed as Pascal's law. So here P1 is equal to P2, and this implies, if I write P1 equal to, let's say, force F1 into area, F1 by area, that is equal to P2, that is equal to F2 divided by area, and this implies you write F2 is equal to capital A by small a into F1. So as area is large, so this implies F2 will be also larger, and another way is small mg by small a is equal to capital Mg by capital A. G gets cancelled, so capital M is equal to capital A by small a multiplied by 7. So in this manner, with small weight, with small force, you can balance, you can lift even heavy object. Is it? Just like consider here in this situation only, let's say if A is equal to 10 centimeters square and capital A is equal to, let's say, 10 meters square. The area difference in area is quite large, is it? So to balance here 2000 kg, capital M is equal to 2000 kg. Let me check what exactly weight I need to put here. So find the weight. Need to put in left arm to balance 2000 kg of mass, right? So that's we can check easily. So this implies, see what will be that. So additional pressure coming this side will be equal to how much? You can write P2 will be equal to mg divided by area is 10 meters square, and this P2, so P1 should be equal to how much? Small m into g divided by area is 10 centimeters square, 10 is to power minus 2. This. Is it? Now these two, that is P1 should be equal to P2 should be equal to 2000 multiplied by g divided by 10. Clear? Just balancing, g gets cancelled and 10 gets cancelled. So this implies m is coming out to be 0.2 kg, and that is equal to simply 200 gram. So now you can see just if area on this side is 10 meters square, area on this side is 10 centimeters square, by just putting here 200 gram weight, you can balance here 2000 kg weight. So that is like principle of hydraulic lift. By just a small force, you can balance heavy object, and this is the application used in hydraulic lift. So hydraulic lift. This is basically hydraulic lift. Basic principle is of Pascal's law. In a confined liquid, externally applied pressure transmit equally in all directions at same level in fluid. And I hope you're clear with this application of Pascal's law. Thank you.